So the takeaways from all this presentation and the tools that we are trying to build here is, first, it can democratize data access. If we are building this tool correctly and if we gain confidence in our tool, it will give all the stakeholders in the company, technical and non-technical alike, the ability to access data, to get the data that they need in order to drive innovation, to make faster decision-making and move on with their projects. And of course, it will empower all the teams in our company, the ones that now will have direct access to the data and the ones that will have less context rich and more time to do the deeper analysis and the more important work that they came here to do. Hello, everyone. I want to start with a story. So this is Michael, and he's from the marketing team in my organization. Michael is now working on a new campaign for our company, and he wants to know, based on the previous campaign that we had, what is the best time of the day to send the promotion for our new sale. Thank you. In order to do so, he goes to ask for help from his data analyst, the one that he always works with. But unfortunately, the data analyst is now on vacation for the next couple of weeks. But still, Michael needs to decide what to do. He needs to make some decisions, but he does not have the data analyst to help him. So what he can do? Michael now has two main options that he can choose from. So the first is to wait for the data analyst until he will come back from his vacation, extract the data that Michael needs, and move on with his plans. And this is, of course, not an optimal choice, because now he needs to wait, he needs to postpone his plans, he needs to postpone this campaign for several weeks. And of course, this is not what we optimally will want to do. The second option Michael has is not to wait for the data analyst. He can look for previous meeting summaries, previous emails, other documentation regarding the previous campaign that we had in order to collect as much information as he can in order to make this decision. But again, this is not also an optimal decision because we don't know that all this information even exists, that we document everything, that we send meeting summaries, and so on. So now Michael is stuck. He needs to make a choice, but none of those choices are optimal and will get him finally to what he wants to get now. And this scenario is true not only for Michael and not only for the marketing team in this example. This scenario is true for many non-technical stakeholders, non-technical teams, and even some of the technical teams in our organization. They all want to get data, to extract data from our database in order to make a decision, in order to understand what's going on in their part of our organization, but they don't have direct access to get this data. The main challenge here that we are going to talk about is the technical challenge. The technical challenge of writing SQL or similar, depends on your database, that they don't know how to do. And that's fine. It's not the job of the marketing team or the finance team to know how to write SQL query, how to extract it from the database. It's my job, it's the data analyst's job, but not their job. But still, we are creating here a dependency between a lot of the stakeholders and the teams in our company to the data analyst in order to make decisions and move on with their projects. Now imagine a world where we can eliminate, or at least reduce the dependency between the data analyst and the other stakeholders in a way that the non-technical stakeholders can ask their question in English and automatically get the results from the database without the need from the data analyst in the middle. This is called text-to-SQL, and this is what we are going to talk about today, where text-to-SQL is the task where you can ask your question, in our example, in English, and it will automatically generate the relevant SQL query to then you can execute it in your database and get the results. Of course, this is based on LLMs, and we will see later how we can create such a tool. Using this task, using text-to-SQL, we will be able to empower everyone in our organization, technical and non-technical alike, will be able to extract data and get data from our database in order to make the decision regardless of their technical expertise. Before we'll talk about the technical solution and other considerations that we need to think about before creating such a tool, I will first introduce myself and in a few sentences the company I'm working for. So my name is Sivan Piam, and I'm working at an Israeli startup called Healthy.io. And in my technical expertise, I'm a machine learning researcher, and I have a master's degree from the Weizmann Institute of Science in Israel in computer science, machine learning, deep learning, and so on. Few sentences about Healthy.io. First, because I think it's interesting, and second, because we are going to use some of it as the use case later in this presentation. So at Healthy.io, we have two main lines of product. The first one, what you can see here on the left, is in the field of wound care and wound management. This is not a real wound, what you see in the image, where we are developing a mobile application and a web portal dedicated for professionals, for wound nurses and wound doctors, in order to help them give the best treatment for the patients by helping them see the wound progress over time, visually, textually, give them insight, and help them make the best decision that they can. And the second line of product, the one in the right, the image on the right, is home urinalysis test. So today, in order to do your analysis test, you need to go to the lab, give your urine sample in a cup, give it to the lab, wait several days until you get the results. So using our product, you can do all this process from the comfort of your home. We are sending the physical kits that you can see here directly to the patient home, and using our dedicated mobile application, you get all the instructions that you need, and then you can do the test from your home and get the results right away on your mobile application. We are going to use this urinalysis test and the use case later, mainly because, as you can see, this product of the urinalysis test involves many different stakeholders in our company, technical and non-technical. For example, those kits that we are sending, we have the operation team that's in charge of sending the kits, of working with the third-party vendor that we're working with in order to send them, and so on. Of course, there is the mobile application that we develop, the patient, the customer support to help the patients, and so on. Now, let's go back to what we want to achieve. So as we said, we're going to talk about the text-to-SQL task, and what we want to do is, instead of the need of writing this query, which might be simple, which might be much complex, we want to be able to write only this, to be able to ask our question in English and automatically generate the SQL query and get the results from our database. And if we will go back to Michael, to see how it affects Michael. So currently, Michael needs to ask his question in English, goes to the data analyst, translate it to the SQL, execute on the database, and get the results. What we want to achieve here is this process. We want to reduce the dependency on the data analyst. We want Michael to be able to ask his question in English and automatically get the final results from the database. Now let's talk about what's in it for me. So what's in it for me, for Michael, I think it's pretty straightforward. Michael will get increased productivity, faster decision making. He will get all the data he needs right away by asking his question in English. But what is less straightforward, in my opinion, is what's in it for me for the data analyst. Because it might sound that we want to replace them, to reduce them, to eliminate them, but this is not what's going to happen here. What's in it for me for the data analyst is that we're going to free the time to reduce the context widget we have and free the time to make the deeper analysis, the more important questions that we want to ask regarding our product, to find the places that we still don't know that we want to investigate, instead of extracting data for other stakeholders in order for them to make those decisions. So before we will start to talk about the technical solution for this text-to-SQL task, for the tool that we want to build, we will talk about the thing that we always need to talk about when we are talking about data and AI, which is privacy and security. So we will focus on three main things that I thought about, but of course there are many aspects of data privacy and security in those aspects. So the first one is the model itself. We first need to choose whether we want to use open source model or not open source model, whether we want to keep our data inside of our organization, or we are fine with sending it to a third party using the API for others that develop their models that we will use. Any choice is a good choice. It really depends on your data and on your needs. In general, when we are talking about text-to-SQL tasks, we are not going to send the data itself from the database, but only the high-level structure of our database. But still, if you have some risk and if you think that you might expose things that you don't want to, it's preferred to use an open source model and deploy it inside of your organization. The second thing here is the user. Not all users are equal. Different users have different permissions to the database, whether because it's their role, it's their geographic location, and we need to make sure that we know how to support it, that no user will get data that he is not allowed to see, and this is very important because we don't want to make mistakes here. The third thing, and the last in this slide, is the data itself. Of course, we want to make sure that when we execute a query that our model generated, it's safe to execute, and we need to make sure that we know how to address it and where are the places in our pipeline that we are going to take care of those stuff. Now let's move on to the solution itself. So we are going to talk about LLM-based solution, of course, and we are going to talk about in-context learning solution, which means that we are not going to train any model. We are going to use a pre-trained model. You can choose whichever works for you depending on your requirements, which means that we are going, again, to use pre-trained models, and it's going to learn about our task and about our database using the context that we will provide it when we are sending our request. So here you can see the high-level pipeline, the process that we are going to talk about, and for how we can build such a tool. Everything starts with the user query. Then we have three main steps: the retrieval, the generation, and the correction. We are going to talk about each one. And at the end, we have, hopefully, we have the output that we want to return for our user. So the first step that we're going to talk about is the retrieval. In the retrieval step, we want to retrieve, we want to collect all the relevant information, all the relevant context regarding our database, regarding our task, everything that we need in order to send it to the LLM, in order for him to be able to generate the query correctly in the sense of the user query and the syntax of the SQL itself. So we will talk here about three techniques or three approaches that we can use in order to increase the probability to get a good query, which are the database schema, few short examples, and categorical text value. Some of those examples are specifically for text-to-SQL tasks, and some of it is general, and we can use it in text-to-SQL task, but it's general for any other tasks that you want to write prompt or to use LLMs for. Let's start with the database schema, which of course specifically for text-to-SQL task. So as we said, we are using a pre-trained model, which means that our model does not know anything about our database, about our question, about our product. And if we wanted to generate a correct query that we can execute on our database, we need to provide it some context about our database, the tables that we have, the columns that we have, and so on. So the first and very important step that we need to do is to provide the context about our database schema. This is pretty simple. You can query it automatically from your database using such a query or similar, again, depends on your database, and you will get a big table where each row is a description of each column at each table that you have in your database, and it will give our model the first and basic context and concept regarding what we have in our database. But in some cases, it might not be enough. In some cases, our database is very complex. In some cases, the names of the columns or the tables include some ambiguity, and it's not that straightforward to understand how to join the tables, which column we need to use at each situation. And at least for my project, what I recommend to add is a description from the schema, which means that for each table and each column, I recommend to add 1, 2, 3 sentences in English about what is the purpose of this column, what is the purpose of this table, when we should use it, just in plain English, so the model will be able to align better between the user query and the columns and the purpose of each column. So I know it might be hard to do it. Like if you have many tables and many columns, it might take time to add a description for each one of those columns. but it's really helpful, and you can start by doing it only for the parts that you know that contains more ambiguity or your model is struggle with, and over time to add more and more descriptions, but it's really helpful and really improve the accuracy of our queries. Next thing we'll talk about is few-shot examples, which is a general technique overall for LLMs, not just for text-to-SQL query, but we will use it also in our task. So what we do in a few-shot examples is to add into our prompt examples. Each example is a pair of user questions and the correct answer, the correct SQL query that we want later to get from our model. You can add here as many examples as you want. As more that you add, it will be easier for our model to learn and to align how to answer correctly the questions. And specifically what I'm doing is not only adding pairs of user questions and answer, but also some examples which might be more technical examples of how to join correctly the tables, how to extract something which is more specific that I know it's more complex to reach and to get from the database. We can also add it here as an example in order for our model to understand and learn how to do it also. The last thing that we are going to talk here in the retrieval, that we are going to talk about categorical text values. So in many cases, at least in my database, we have columns which contains categorical text values. And the column have some name which does not explicitly indicate which categories we have in this column. For example, in my project, we have a column where the name of the column is interaction type, which contains all the different interactions we have with the user. It can be sending the kit, it can be calls, we call the user can call us for help, we send emails, we send SMS, and so on. But you can't infer directly which type of interactions you have in this column. So when a user comes and asks, for example, how many calls were done in the last month, the model does not really know how to filter only for calls. He does not really know how to connect between the calls that we want to filter by and the relevant column, which in this case, interaction type. So what really works here is to add explicitly, and it's pretty simple, all the relevant categories for all the columns that we need. You can map all the columns once, or all the ones that you think that you have some risk or ambiguity that you want to add here. And every time that you need, you can query all the distinct values automatically and add it to the prompt, whether it's in a different part of the prompt or whether adding it to the description that we talked about in the previous slides. But just adding the categories in your columns really helps our model to understand how to filter correctly. Otherwise, he will try to filter, for my example, the calls from some other column that he thinks which might be relevant, instead of just providing him the context in order to do it accurately. Great, so now we retrieve all the relevant context. We have everything, hopefully, everything that we need to provide the LLM to understand what we want and how he can do it. And now we are going to talk about the generation itself. So the next step is to ask our model to generate the SQL query that we want to use. And also here there are many techniques. We are going to talk about only two of them, but there are many techniques and many variations of how to help our model and how to instruct it to generate its output, in our case, the SQL query, in order to get more accurate results. So we are going to talk about chain of thought, which is, again, general techniques for LLM, not specifically for text-to-SQL. And we are also going to talk about subquery decomposition, which is specifically for text-to-SQL. Let's start with chain of thought. So what we are trying to do when we are using chain of thought is to instruct our model to break down the complex query, the complex question that we get from the user into smaller steps, like to create a linear process contains smaller and easier steps to answer, where when we are getting to the final question, the final step in this process, we get the final answer that we want to return from the user. The main idea here, which will we talk also in the next slide, is to help our model to break down complex tasks into more easier subtasks, which is easier to generate, easier to understand, and easier to answer. So how you can do it? First, you can do it by crafting your prompt and directly asking your model to break down the task into a process of sub-question, sub-task, and generate and answer the question accordingly. And you can also add it in your examples. You can add your examples by using chain of thought, like asking the questions and the answer will be the step that you want it to do. Like filter for these columns. Use those tables. At the end of the example that you use, as you can see here, you write the final query that you want to get. So you can break down the example that you add to your prompt in order to help him to understand how to break down the user query. Next, we will talk about subquery decomposition, which is specifically for text-to-SQL. And it's basically, the high-level idea of it is pretty similar to chain of thought. Also here, we want to help our model to break down a complex task into smaller and easier steps. So now what we want to do is to help our model generate a correct SQL query in a correct syntax that we will be able to use. So what we want to do here is to instruct our model to break down the generated query into smaller subqueries. You can use, I'm using here common table expressions in order to define it very carefully, each part that I am breaking down my question. And then our model will answer each one of those parts, will generate subqueries which are easier to understand and easier to generate. It's not complex joins, not complex logic. It should be pretty straightforward, simple queries. And at the end, we can join everything together to get the final results. And again, it really helps our model to generate more correct syntax and more correct queries because we help it to break it down to smaller steps that he is able to generate for us. Great, so we retrieve the context, we generate the query, now we have the query, and our end goal is to execute it and return the output for our user. But before we execute the query in our database, we want to make sure that first it's safe to be executed, second, that we can give the output to our user using its permission, and in some cases, unfortunately, the generated query will not have a correct syntax, and we have also a way to create a feedback loop in order to correct the syntax. So let's start to talk about database modification. So of course, the first thing that we want to do before executing it in the database is to make sure that it's safe to be executed. We want to make sure that our generated query does not include any modifying keywords, delete, alter, create tables. We want to keep our database as is without changing it, hopefully. Of course, this is also the place to talk about the user permission. This is the place to understand and to check that we are not returning any data that our user is not allowed to see. So again, this is a place to do it before we are executing the query. After we have a query that we know that it's safe to be executed, we get the results from our database. In many cases, we will get a result that we can return to our user, but in some cases, the syntax of the query might not be correct, and we will get error from our database. This error message, most of the time, are pretty informative that we can use to understand where the syntax is wrong. So what we can do is to create the error that we get from our database. We can create the query, we can we can take the user query, the error and everything, and feed it back into our model and ask it to generate again. So this is the error that I get by executing this query. Can you please fix it for me and generate a new one with a fixed syntax? And it really works. In most of the cases, it will fix the query and generate a new one that you can execute in your database and get the result for your user. Now we get the output, hopefully, that we can return for the user. We can return it again in English. The user asks in English. We can return the results in English. We can also provide the SQL query itself if we want to validate it, to save it, to run it later again, anything that we want to do. You can return to your user at which type of output that your user wants or need. Now that we understand how we can build such a tool, and we know that it's great, let's talk about the challenges. So there are many different challenges that we can talk about here. It's not that simple to create such a tool, but I want to talk about some of them. The first one is about the conversion between text to SQL itself. So what we are trying to do here is to convert English question, which might be complex, the English language is complex and it contains many ambiguities, to an SQL query, which is very strict and very defined query or very defined syntax, and it's not that straightforward to do it. In many cases, your model will not really understand what you are asking him, and or you will get an error, or you might get some query that not really answers what you wanted it to answer. So we need to understand that this task is complex, and one way to improve is, of course, to improve our model, to give more examples. If needed, you can train it, not like in this example that we use pre-trained model. You can craft your prompt and use other techniques, but this challenge is existing always. Another option or another side of the same thing that you can try to do in order to improve your output is to train your users. So in some cases, it's not that easy because you have many users of your product outside of your company. But in this case, when we are talking about internal tool for your company, it might be easier to train them and help them to understand how to craft their query correctly without ambiguities, how to ask the questions in a way that the model will be able to help them and get them the results that they need. But of course, it's still challenging if you want it to your users. Also, if your company is a big company, you can't really train everyone, but it's one way that can help to improve your result, again, especially if you are using it, like in this example, as an internal tool. The other challenge that I want to mention here is how we are going to validate it, both in the development phase and, of course, in production. So if you're talking here about the development phase, it's also not that straightforward how we're validating the query itself, because for each question we are going to ask, there are many different variations of how to write a correct query that will give us the correct output. So it's not easy to validate the query itself. What we can validate is the output that we get from the database to make sure that this is the output we are expecting to get. But it means that we are not explicitly validating what the model generated, what we want, what we really want to get here. And it means that if we want to validate that it used the convention that we want, shorter queries, longer queries, more efficient queries, it's challenging, and we need to think how we can do it, if we can do it at all. In the production part, which is even more risky here because there is no one who can go over our answers and the queries, it's again the question that how we can validate it. We need to be very confident in our tool before we deploy to production, especially if it's not as internal tool in your company, because your user, after all, does not know SQL. This is where we start all this project. And he does not know if your query that you generate is correct or not, whether he should not use the output that you gave him. So this is, again, a big challenge, and you need to be very confident when you are giving this tool to your users. OK. So we talked about the challenge, we talked about the tool, we talked about everything. Now let's see how we can use this tool and why, in my opinion, it's very helpful to create such a tool. So everything, again, starts with the user input. We generate the query, and at the end, we retrieve the data and return the output to our user. And let's say that in this example, if you're going back to the urinalysis tests, we have the following entities. We have the patient that wants to do the test. We have the interactions with the user, whether it's kits, whether it's the calls. And we have the scans themselves. The user takes a picture of the test in order for us to give him the results. Now let's see how three different teams, three different non-technical stakeholders in our company can use the same tool without the need, hopefully, the data analyst in the middle. So we will start with what we have today. So today, our management want to know information about the KPIs in the company. In this example, they want to know how many patient scans, how many patients really used our product. And in order to do so, they need data analysts to write the SQL query, to get this data, to give them the output in order to get this information. Different team in the organization also want to know to get some information from the database. We are talking here about the operations team, which again in charge also about the kits delivery in our product, and they want to know how many kits delivered but did not arrive yet. They want to know if we have some issue with our third-party vendor, and they need data analysts to be able to write the SQL query and filter correctly all the relevant filtering that we want to do, only for kits, only for specific time frames, and so on. So we're talking here not only about the technical expertise of writing SQL, but we're talking here also about the familiarity with the database, with how to filter correctly everything that you do. And if our database is complex, if our database is large, sometimes there is no one data analyst that is familiar with all our database and everything that's going on there, and you need several data analysts in order to give you all the data that you need. The last example here is the customer support. They want to know how many incoming calls were done in the last month in order to prepare for the next month with the number of representatives. And again, they need someone to extract the data, to write the query, to filter it correctly, and give them the information. But now, using this text-to-SQL task, using our new tool, they don't need this data analyst, one or more than one data analyst in the middle. They can all use this one tool that gets the schema of the database, that is familiar with all our database, all the context that we provide them, and they all can ask the query, they ask their question in English and get the result directly from the database. So the takeaways from this, from all this presentation and the tools that we are trying to build here is, first, it can democratize data access. If we are building this tool correctly, and if we gain confidence in our tool, it will give all the stakeholders in the company, technical and non-technical alike, the ability to access data, to get the data that they need in order to drive innovation, to make faster decision-making and move on with their projects. And of course, it will empower all the teams in our company, the ones that now will have direct access to the data and the ones that will have less context switch and more time to do the deeper analysis and the more important work that they came here to do. Thank you. Thank you for listening. Thank you for coming. Thank you.
Thank you very much, Sivan. Do we have any question?